argument. Okay, the program argument is where on our local machine we can add the input and output here. See, where are my folders? Okay. This is a path to my data. Path to output. Okay, here I need to remove the output folder. Oh, those are warnings, so no worries. Okay, here an output folder is generated. In Hadoop, the output of a job will look like this part something. That's because that's a result returned from multiple reducers. Okay, here there's only one reducer, so it's only one part. We can check, okay, that's the year, that's the max temperature. Since this is multiplied by 10, so the max temperature in 1902 is 24.4 and 28.9 for the year 1903. Okay, it's successfully finished, and we didn't see the counter information, even though we had a system error print line, because that's some different string. We will be able to see them when we run this project on the server. Okay, then how can we jar this project and run it on the server? Okay, we still go to this run configuration and Maven build. Okay, double click and it has a new configuration. We can rename it max temp counter 3. Oh, that's Maven. Okay, and the basic directory we can choose. We choose this one. Okay, and the goals clean package. Okay, and here jar. Okay, make sure you are not using JRE and you are using the JDK. Then okay, let's click on run. Okay, it's finished, and it generated a jar at this path. Yeah, and next I'm going to upload this jar to to the AWS server. Okay, here I have already logged onto the AWS server. And I need to copy it. Let me see. I could copy. Okay, SCP is we copy from local to server or from server to local. This -I is to indicate the public, the key. Okay, the public key for connecting to the server. This -R represents recursively copy. Oh, actually, I don't need to copy it recursively because jar is only one file. And the file that we want to copy from this max time counter 3 something.jar is the one we just created, and my AWS server has the server name. Since I have this key, I don't need to have any username and so on. Okay. Demo. We are doing a demo now. Okay, now we have successfully uploaded this jar we just generated from local to the server. And on Hadoop, I have already copied 2 data sets. One is the example data, only includes 2 years of data, and this max temperature data, I think it's around 20 years of data. Okay, this is the code I used to run it previously, and we just change to this new jar. Okay, so this is the name of Hadoop jar, the name of this jar, and the package. Okay, this package name, the package name, and the class with the main function, and the input. Okay, the input and output. Yeah, it fails because the output exists, so it won't automatically delete the output file. We have to do it. Manually. Hadoop fs remove recursively the output file name here. Okay, now let's try it again. Okay, so it's completed successfully. Oh yeah. And okay, so here are the output of our counters. The temperature quality has two values, 1 and 9, and there are so many records with a value of 1 and 43 records with a value of 9. And okay, so this is the group we define in the enum, and this is the counter name. So the temperature, there are 43 missing records, and there seems to be no malformed records for the temperature field. And our output file is at Hadoop files. So our output file, our output directory has three parts. So it's done on 3 reducers. And now we can take a look at the outputs. Oh, sorry. Hadoop. So without Hadoop FS, it's actually looking for this file locally on the server. Okay, now we have the results, and that's sorry, where is it? It matches the value generated from our local. We run it on our own computer. Well, the parallel computing will benefit when we have an extreme large data set. Since for the large data set, the records will be similar, so it's usually very good practice to run it on small data sets, and then after the program is tested, to run it on the large data set. Okay, that's all for this demo.